I am reading George Dishman today. Um, it seems like I'm 5 days behind now. So I'm going to just read this and see what happens. I've been having an argument with George Dishman for the last few days and some of the other stuff I've been doing, and I haven't had time to look closely at what Paul Gradenwitz has been saying. So Paul says for general relativity theory, we don't need for the mathematics a fourth spatial dimension, and he completely agrees. What he sees is that he can't make a space that has global curvature without embedding it in a fourth dimension. So time, um, embedding, uh, because I think that space should not need to be embedded in a fourth dimension. I have my problems with general relativity theory. I'm not really following this. On the other hand, you might know that some dents in the CMBR are taken by some astronomers as an argument that we see how another 3D parallel universe is touching our universe. I really have no idea what any of this means. I completely can follow with your Euclidean descriptions and like the way you extended it to events. That was something George was doing here, and I was suggesting that a Euclidean point actually has two parts. A Euclidean point has duration and velocity, whereas an event is that which has no part. George was arguing uh, a line is a length without breadth, and the extremities of a line are points, and he added an event is that which there is no part and no duration. So he didn't change the definition of, he wasn't willing to change the definition of point to a uh, a point is that which has no part except duration and velocity. But he does want to change the definition of event to that which has no part and no duration. He wanted to say a worldline is a duration without spatial extent, and I'm saying that is actually a Euclidean point is a duration without spatial extent, because a non-Euclidean point is one that is moving, and it actually has a spatial extent because it has a x component, a direction, uh, some direction to it. And then he says the extremities of a worldline are events. I did not agree with his description of the way he extended his Euclidean descriptions, because his Euclidean descriptions would not. He was basically just refusing to acknowledge that a point has duration and velocity. He did not want to acknowledge that, and so he I do not agree with George's description of a Euclidean point. I like the idea, though. As a matter of fact, I feel like it's kind of I feel like came up with a conversation between me and Sean Genovese, who's a high school math teacher somewhere in somewhere in Macomb with me, and he was describing Euclid's elements and describing the beauty of that definition of a point. And I was like, dude, a point does have parts. It has a duration and a velocity. So I was kind of starting to think along these lines of putting these things together, um, and kind of changing what it means to be non-Euclidean. And to me, I think the idea of non-Euclidean should be uh, having points with velocity. Um, those would be a non-Euclidean point. Um, but George was just wanted to argue, so he came up with his own ideas, and now they're apparently achieving some popularity with Paul Gradenwitz. Anyway, let's move forward. George said, What did he say here? I understand what you do here. You take 3D space reality and represent a 1D part of that in a Minkowski diagram. So George is saying, consider a uniform spherical shell with radius r and thickness dr around a small test mass m. He doesn't specify, so I'm going to put the test mass over there. We omit the z-axis, so the intersection of this with the xy plane. So x, xy plane is a circle around a dot. We also omit the y extent, so that the representation on the x-axis is a dot with two short lines of length dr, um, starting at a distance r from the dot. On an xt Minkowski diagram, these become three parallel world lines. So yeah, if this is x, so in a map of x versus t, assuming that this dr lines up with that, we're going to get a world line here where the mass is, here where dr is, and here where the dr is. And these are going to be parallel world lines in the x versus t map. And Paul says, I understand what you do here. You take a 3D space reality and represent a 1D part of that in a Minkowski diagram. And he says the first image is of an iceberg calving from a glacier at the head of a straight fjord. Are you with me so far? And George says, again, I understand that the two tugs cancel the iceberg's small test mass forces. The flow in the fjord would be the flow of time. So I just realized I need to know what a fjord is. A long, narrow, deep inlet of the sea between high cliffs, as in Norway and Ireland, typically formed by submergence of a glaciated valley. So it's a long, narrow, deep inlet. So I guess he's picturing like an inlet and then going out to the sea and an iceberg calving from a glacier. So we've got an iceberg, glacier at the head of a straight fjord. Maybe there's an iceberg and a glacier over here, right here. I'm not sure. Are you with me so far? Maybe. But Paul says he understands the two tugs cancel the iceberg small test mass forces. The flow in the fjord would be the flow of time. What? No. Is what I was saying. I think earlier I mentioned I don't like arguing from analogy because analogies. I had earlier said I'm far past the point of learning from such analogies, and I find that in others, such analogies will largely just lead them to misconceptions and false expectations. But who said this? George said this. It's not an analogy. That is how the maths of general relativity works. General relativity says space-time is curved. The analogy was the icebergs moving north. I'm not sure if I agree with that or not. The more I look at it, the more I think the maths of general relativity is, well, yeah, well, I have no idea. All I can say right now is that I don't understand the the iceberg moving north. Okay, we've got an iceberg moving north. There's nothing analogous with the iceberg moving north. We're just describing an iceberg moving north. That's what I see. Okay, but anyway, so let's think about this. I think Paul brings up an issue here. The two tugboats are at the same level of simultaneity as the iceberg. As such, they have no reality for each other. What you describe has no reality for our problem. And so So Paul is thinking that the flow in the fjord is analogous with the flow of time in the problem. And since the last two videos I've made have failed, I'm going to stop this one now at 10 minutes. So thank you for watching.